Dr. Joe Marchant holds a PhD in genetics and medical microbiology from St. Bartholomew's Hospital Medical College in London, and a Master's of Science in Science Communication from Imperial College, London. She has served as senior editor at New Scientist and Nature, and her articles have appeared in many, many notable magazines and publications. Her interests include, and they're very impressively large, exploring the human relationship to the universe, the science of the mind-body connection, past civilizations, and the power of the night sky. So all very, very large topics. She doesn't think small. As part of her science publishing, she has written on the history of King Tut's mummified body and the science of mind over body. And she's published notable books about the sky. We were originally inspired by her book, Decoding the Heavens, Solving the Mystery of the World's First Computer. The publication of that book was the occasion of her first visit to the villa to give a Villa Council Presents talk in 2010 on the technology of the Antikythera mechanism, which is an ancient analog computer for predicting astronomical events. And that talk is still available on Getty's YouTube channel. Most relevant to us today is her 2020 book, The Human Cosmos, Civilization and the Stars, also called, because it's published in two places, A Secret History of the Stars. That book is a sweeping look at humans and our relation to the heavens. And her talk today on how the stars have shaped humanity addresses themes of that book. And by the way, that book was a best book of 2020 by NPR, The Economist, Smithsonian, and many more. Please welcome Joe Marchant.
Hi, thank you, Shelby, for that lovely introduction. Thank you so much for coming. I'm really excited to be back here. It's taken me 15 years to get back to the Getty Villa, so I'm really happy to be here to talk to you. What I want to talk to you about today is something that is so powerful that just looking at it, just experiencing it, has all kinds of benefits for us. It makes us more creative, more curious, less stressed. We become more joyful. We even feel as if we have more time, because that is exactly what psychologists have found for the stars. The starry sky is one of the most powerful sources we know of the emotion of awe. So that's the feeling you get when you're confronted by something vast that dwarfs you, that you it's just beyond your capacity to comprehend. And in studies, psychologists have found that awe boosts our well-being in all of the ways I just mentioned, but it also does something else quite interesting, which is that it shifts our perspective, our outlook on life. After experiencing awe, people become more generous, more outwardly focused. They feel more connected to the people and the environments around them. They're more likely to help a stranger. They care less about money and more about the planet. So it seems that just experiencing what's beyond us, the vastness of the universe for ourselves, shifts our thinking in a really important way. We're less focused on those selfish daily small concerns that seem so important, and we're able to see ourselves as part of a bigger picture. But just as we're realizing how important this view might be, we are losing it. Every society through history has looked up and been inspired by the spectacular, glittering heavens, the stars circling every night until now. So in today's cities, instead of thousands of stars in the sky, we see just a few dozen. Even on a clear night, a third of humanity can no longer see the Milky Way, our galaxy, at all. Artificial light pollution is increasing by about 10% every year. And in the meantime, communication satellites are being launched, thousands of them, so that they're set to soon outnumber the stars in the sky. So if these trends continue, then our view of the stars will soon be gone. And one of the questions that I keep coming back to in my writing is, what does that mean for us? Does it matter that we're losing the stars? So what I want to talk to you about today is what the stars have meant through history, how they've inspired people, and whether they're still important today. So what do we lose if we lose our view of the stars? So I'm going to do kind of a quick history of the universe, if you like. So not a scientific story, starting with the Big Bang and following the evolution of galaxies and solar systems, but a human story, following our changing connections with the stars. So from cave paintings and stone circles through to the development of powerful telescopes, our ability to travel into space for ourselves. And of course, that is a very big topic. So I'm just going to pick out a few episodes and themes that I think are important before coming back at the end to that idea of awe. So if we start at the beginning, let's go all the way back to the Paleolithic era, and in particular to Lascaux Cave in France. I should say some of these pictures are from replicas of the cave because you can't go into the original now to take photographs. But this cave is world famous because of the beautiful paintings that cover its walls and ceilings, these animals, horses, stags, aurochs, bulls. They're around 17,000 years old. So this is a glimpse into what was going on in the minds of some of our very earliest ancestors. And I think this is one of the most intriguing paintings in the cave. It's an aurochs bull, the largest bull in the cave. It's more than 5 meters long. And in particular, you can see it's got this distinctive pattern of dots above its shoulder, a line of 4, a line of 2. There it is. And interestingly, that same pattern of dots keeps showing up in art through history around the planet. You see it in Native American art, Siberian shamans' art. There's even an adapted version in the logo of the Japanese car maker Subaru. And all of these other examples are representing a star cluster, the Pleiades. So that raises the question of, well, could the Lascaux dots be showing the Pleiades as well? And what makes that comparison even more striking is that positioning at the shoulder of a bull, because it's really similar to where the Pleiades are in our modern constellation of Taurus. And that's not the only similarity. You've got those forwards pointing horns, the prominent eye, that's the star Aldebaran, the speckles on the face, that's another star cluster, the Hyades. So this is all led to the suggestion that maybe the people of Lascaux weren't just painting animals, maybe they were painting maps of the stars. And when I first heard about that, I was just really fascinated. I wanted to know, well, could that possibly be true? Like if they did link the Pleiades to a bull, could that possibly have survived that relationship until now? And why would they have been so interested in the stars anyway? Why would they have wanted to connect the Pleiades to a bull? And unfortunately, we can't know for sure what they were thinking. They didn't write that down, unfortunately, but there are different ways in which we can get closer to the mindset of what they might have been experiencing. And one of those is to look at the lives and beliefs of hunter-gatherer communities who've lived more recently, who anthropologists think may have led lifestyles similar to that of the people of Lascaux, people like the Chumash people who lived until recently in California, for example. And what you see over and over again is that the cosmos, what's going on in the sky, was absolutely central to the lives and beliefs of these communities. You see it in their stories, their rituals, their art, the design of their homes. So the Chumash, for example, had a very intricate cosmology, the sky filled with living beings, like the sky coyote, which is our star Polaris, which they thought gambled with the sun over the fate of the people below. They had cave art full of celestial symbols, and they had rituals. For example, at the winter solstice, the shortest, darkest day of the year, they'd plant special sticks into the ground tipped with quartz to try and persuade the sun to return, to sort of draw it back on its course towards the spring. And the reason that what was going on in the sky was so important was because before people were shielded by technology, the sky really did convey important information that was vital for survival, that was really relevant for people's lives on Earth. So The sun is a fairly obvious example. So the cycles of the sun through the day and night, through the year, is determining whether it's hot or cold on the earth, whether it's light or dark, whether life is thriving and growing or lying dormant. But the moon was very important as well. So with its changing phase, that changes the light levels during the night, and that's important for activities from hunting to sleep. The moon regulates fertility and reproduction in many species, possibly including humans. And then we've got the stars. So astrology today is often dismissed, but the stars really did once convey very important information that was relevant to life on Earth. So first of all, they track time. Oh, well, time and place. So because the Earth is spinning on its axis, the stars appear to circle in the sky each night around a stationary point called the celestial pole that is going to be directly above either the North Pole or the South Pole, depending on which hemisphere of the planet you're in. And so the direction of that pole in the sky tells you which way you're facing. So if you're facing north, and then its height in the sky tells you your latitude. So how far north or south you are. So that's really important information for navigation, for example. And the stars also track time. So they're circling through the night, rising and setting on the horizon, and that kind of acts like a clock tracking hours through the night. And then the stars are also marking the seasons. So as the Earth travels around the sun through the year, different constellations become visible in the sky. So that means that different natural and seasonal changes that are happening down on Earth, whether that's rutting deer, ripening fruit, the arrival of rains or snow, that is heralded and then mirrored by changes in the stars that you can see in the sky. And so for that reason, stars appear in lots of traditional calendars, so people tracked where they were in the year according to the stars that were visible. And the Pleiades, a very distinctive star cluster, which is visible at some times of year and not at others, features in a lot of these calendars. So in New Zealand, the rising of the Pleiades signals the beginning of a new year, for example. In Africa, its rising signaled the coming rainy season. Relevant for our interest in bull number 18, for the Native American Blackfoot people, they associated the visibility of the Pleiades in the sky with the life cycle of the bison, which they hunted. So when the Pleiades set, for example, that meant that it was time to hunt. And that's led to the suggestion that maybe the people of Lascaux could have had similar calendars for the animals that they hunted. Studies suggest that this changing seasons was very important to whoever painted these animals. So each of the animals, the horses, the stags, the bulls, studies show that they were painted at different times of year and each during the mating season of that animal. An astronomer has also calculated that at the time the animals were painted, the visibility of the Pleiades in the sky would have quite nicely marked the mating season of the Aurochs bull, which they hunted. So maybe the hunters realized that as well and made that connection between the Aurochs bull and a giant bull in the sky. If so, could that link have survived from the Paleolithic until now? Taurus we don't know its origins. It's one of the oldest star constellations that we know of. It does go back at least 7,000 years to the Mesopotamians. We don't know before that. But there are other examples of stories told about animals in the sky that perhaps have survived that long. One example is a myth called the Cosmic Hunt that appears in lots of different versions all around the planet. The basic story is that an animal is chased by hunters and then escapes up into the sky to become a star constellation. And which stars, which animal varies in different places, but you find the same basic story in Europe, America, Asia, Africa. This is Paleolithic cave art from Siberia, which is thought to perhaps represent an early version of the Cosmic Hunt. And here we've got the Greek version with Callisto, who then goes up into the sky to become Ursa Major. And researchers there was a study a few years ago where they collected together all the different versions of this story from around the planet and looked at the differences between them and came up with a kind of family tree to show how the story had changed over time. And they concluded that the original version of that story must have begun in Paleolithic times in Eurasia. So that is an example of a story being told about animals in the stars that perhaps has survived from the Paleolithic until now. Does that mean that the bull at Lascaux is a map of the constellation that we know as Taurus? And we can't say for sure, unfortunately, but if you look at all the different lines of evidence, I think it's fair to say that these paintings were as much about cosmology as biology, reflecting seasonal changes that were happening on Earth and in the sky. And certainly the people of Lascaux would have had a constant experience of the sky as telling them vital information about time, place, climate, nature, the eternal cycle of life and death. So they lived in an interconnected, holistic cosmos immersed in the sky where the stars, the seasons, the natural world are all changing together through the year as one connected system. So when did we start to break apart that holistic cosmos to separate earth and sky, split ourselves away from nature? Or I think we can get a really interesting insight into that if we jump forwards to Turkey now and a site that dates to the 10th millennium BC called Göbekli Tepe, the series of stone circles on a hillside there. And this site dates just to the transition between the Paleolithic era that we've been talking about and the Neolithic, which followed. So this is thousands of years after Lascaux Cave, but still 6,000 years or so before Stonehenge in England, say, or the Great Pyramids at Giza in Egypt. And archaeologists think that these sites represented a model of the cosmos. They were built as a portal to other realms. And there were two key shifts that characterized the switch from the Paleolithic into the Neolithic. And one of those is the crucial invention of farming. So when people first started to exploit the species around them for agriculture. And the other is this buildings of giant monuments in stone. And it had been traditionally assumed that farming came first. So presumably triggered by environmental changes, and that enabled people to live in more settled communities with a more predictable food supply, and that enabled the organized labor necessary to build sites like this. But Göbekli Tepe turned that upside down when it was discovered, because this was built just before the invention of farming and at exactly the place where farming was about to arise. So it seems that something interesting happened here. If we look a bit closer, so we have these stone circular enclosures, and in the center, these two giant pillars, T-shaped pillars. But it seems that they were intended to represent human-like figures because they have belts, arms, necklaces, loincloths. There is some celestial symbolism. So, for example, there's a disc and crescent on one of the columns, which has been suggested to represent the moon, and also apparently an obsession with death. Archaeologists have found hundreds of human skulls here that were hung up inside the circles. And they were dug down into the ground, probably covered over, and they didn't have doors. To get inside, you had to crawl through a porthole. And the archaeologists working here think that they represented the underworld. You would crawl through the porthole into this dark, sacred space surrounded by the human skulls and these terrifying transcendent beings. So this was the cosmic realm of the dead. And all this represents a very dramatic shift in how people related to their environment, their cosmos. In the Paleolithic, the art we see is mostly of animals. There are very few depictions of humans. Here there are some carvings of animals, but they're smaller. It's these human figures that are really giant, that dominate. There's a shift from animals in the sky to these spirit realms filled with human ancestors. So there's overall there just seems to be a shift where people are starting to see themselves as dominant over or raised above nature. There's this growing self-awareness. And then there's also people are starting to take control rather than just painting on existing cave walls. They're building their own portals to other realms of the cosmos. And then later in the Neolithic, there are other stone monuments with celestial significance. So, for example, Newgrange Tomb in Ireland, which is perfectly aligned to the winter solstice so that the sunrise on that day sends this shaft of light right into the heart of the tomb. And then a few centuries later, Stonehenge in England, for example, also aligned to the solstices. And these monuments as well have been described as bridges to other worlds, portals intended to link earth and sky, the realms of the living and the dead. And then the pyramids in Egypt, built around the same time as Stonehenge, they're aligned differently to the northern celestial pole where the stars circled and never set. So those stars were associated with immortality. But there was a similar purpose to help the buried pharaoh travel towards an eternal existence with the stars in the sky. So there does seem to be this lasting change in cosmology as you go into the Neolithic, with people seeing themselves as dominant over nature, taking control, building their own portals to other realms. And going back to Göbekli Tepe, linking that back to that crucial invention of farming, it seems that this shift in cosmology and mindset and our relationship with the universe is what happens just immediately before. And perhaps it was this that the archaeologists are suggesting that made farming possible, made it conceivable, and then set the stage for all of the exploitation of nature and technological progress that followed. So up to now, we've been gleaning clues from paintings, monuments, but let's jump forward now to the first written records of beliefs about the sky and the birth of an idea that has been really influential in our history, which is that our fate is written in the stars. So the Mesopotamian invention of writing gives us our first sort of direct insight into what was going on in the minds of an ancient civilization. We have hundreds, thousands of clay tablets like this one, whole libraries dating back as far as the 2nd and 3rd millennia BC, detailing every aspect of life from poetry to taxes. But what jumps out more than anything is an absolute obsession with what was going on in the sky. So for the Mesopotamians, events in the sky were still absolutely entwined with what was happening on Earth. And this was common among ancient civilizations, but the Mesopotamians really took it to extremes. They compiled books of omens, were linking events in the sky, so a planet changing direction or the appearance of a sunrise, to terrible things that were about to happen on Earth, things like famines or wars. A lunar eclipse, for example, probably because of this blood red color, was often associated with the death of the king. And knowing that these omens were through the omens, and knowing what these events in the sky meant, that enabled people to conduct rituals to dispel the evil and stop the terrible things from happening. So if a lunar eclipse said that the king was going to die, for example, then the king might temporarily step down from the throne, put someone else there instead, like a beggar or a criminal, then execute them. So the omen would have safely come true, and then he could go back to his throne. So rulers had strong practical reasons for paying attention to what was going on in the sky. They often had teams of official astronomers to do this for them, to help them stay ahead using the omens and stay in power. And really the best at this were the Babylonians. There were priests there who were carefully watching what was happening in the sky night after night, literally for centuries, noting down everything that they saw in astronomical diaries. This is a depiction of what the city of Babylon may have looked like around the 6th century BC. This is the famous Gate of Ishtar, Venus, that took you into the city. And on the horizon there, you can see the Tower of Babylon. That was built as the gateway between heaven and earth. That was where the astronomers conducted their nightly observations. And because they kept such meticulous records over such long periods of time, over the centuries, they started to make sense of what they were seeing, to notice repeating patterns, even in things that hadn't been obvious to begin with. And they called so they identified what they called great cycles, which were periods of time after which events roughly repeat. So the wandering path of the planet Venus, for example, repeats every 8 years. Patterns of eclipses repeat every 18 years. So they're starting to make sense of what's happening in the sky. And then around 400 BC, they came up with an invention that made them even more powerful, and that was the 12 signs of the zodiac. So as the Earth moves around the sun through the year, but the sun appears to take a path against the stars in the sky. And long before this, constellations had been identified around that path. It's called the ecliptic, the path the sun takes through the year. But what the priests did at this point was they took that 360-degree circle and divided it into 12 segments of 30 degrees each, and named each one after a nearby star constellation. And the reason that they did this was so that they could note down even more precisely the locations of these different events that were happening in the sky. It was like making a giant measuring scale in degrees, like a protractor in the sky, so that they could make more accurate numerical observations. And that enabled them to then come up with complex mathematical rules, algorithms for modeling the movements of the different celestial bodies and to predict what was going to come next. So this tablet is showing very accurate calculations for the timings of series of new moons, for example. So now they really could foretell the future. And I think that this was a really important moment in history, because the astrology that they had, they wouldn't have called it that at the time, but the astrological beliefs have been really influential. But also alongside that was this numerical approach, and that has been really important as well. So the Babylonians were the first to use maths, numbers, to make sense of the sky. And that's been really important in laying some of the groundwork for our scientific worldview that we still have today. So we started with that holistic cosmos, humans and nature, earth and sky all entwined. We had the first step away from that with the birth of agriculture and the first use of numbers to make sense of the sky. But that increasingly mathematical approach to what was happening with the stars also over time led to other really big changes in how we related to the stars and to our environment. For example, with our sense of time. So through most of history, time has come directly from the sky. So hours, days, months, years, all of this is coming directly from the cycles and the paths that the sun, moon, stars are taking in the sky. So it's our experience of those cycling motions. But in ancient Greece, they came up with a technology that would eventually completely change our idea of time. So I had to bring the Antikythera mechanism into here somewhere, because it's really my favorite thing. It's an incredible object, by far the most sophisticated, complex object we have that survives from the ancient world. It was found more than a century ago on a shipwreck close to the Greek island of Antikythera, and it's was made of bronze and had dozens of interlocking gear wheels inside it. And there's also the remains of dials, pointers, inscriptions. And it's been reconstructed recently as a little model universe, if you like, a portable cosmos. And it's really all about time. You turn that handle on the side to move forwards and backwards in time, and then the pointers, the sort of little portable cosmos, moves with you. These pointers are showing you the changing positions of the sun, moon, and planets in the sky for any date that you want to look at. These inscriptions are star calendars about the risings and settings of the constellations at different times of year. On the back there are more dials. There's another calendar, and there's even an eclipse prediction dial that's telling you whether you can expect solar and lunar eclipses on different dates. So it's this use of gear wheels to track time by modeling those motions that we see in the sky. And when the Roman Empire eventually collapsed, this technology was lost apparently from the West, but it did survive in the East. So this is an astrolabe from the 13th century from Iran. And inside, it's got this hidden geared calendar, simpler than the Antikythera mechanism, but it seems to be a direct descendant of it. So 8 gear wheels that model the motion of the sun and moon in the sky as you turn a little knob, and they're shown on the back. So the sun and the moon in the sky, it shows you the phase of the moon and the day of the month. But this technology then eventually made it back to Europe, where it helped to inspire the invention of mechanical clocks that could run themselves. And these then swept very quickly through Europe. And at the beginning, as you can see from this example that's still working in Prague, they had a lot in common with the Antikythera mechanism. These early clocks didn't just tell the time, they were basically little model universes. They were showing the movement of the sun, moon, planets in the sky. Often they predicted eclipses as well. So time at this point was still seen as inseparable from the celestial motions of the sky. But what happened over the next few centuries was that as these clocks became more accurate, they ran at a more constant speed, they actually became more accurate, more regular than the sun in the sky. And so eventually clocks dropped those astronomical displays, and now they're not modeling the sky anymore, they're telling the time in their own right. And time, rather than being an experience of the sky, became much more a numerical quantity, something much more like money, actually, that we spend, buy, waste, count, save. And our time is no longer held in the sky, it's held in our machines, in our clocks. I just wanted to mention quickly that something very similar has happened to our sense of place. So through most of history, people would have looked to the stars to navigate, to know where they were, particularly sailing on the ocean where you haven't got landmarks to follow. So the Polynesians are a good example of that. They took bearings by following sequences of stars rising on the horizon. They also looked really carefully at changes in weather patterns, water currents, wildlife. So they were really immersed in their environment, like so sort of sky and sea together. And through that approach, they were able to navigate successfully over hundreds of miles of open ocean. But in the West, of course, sailors, scientists took a very different approach, relying more and more on mathematical charts, instruments, observations, and that's enabled us to develop really powerful technology to the point that we no longer need to look to the sky to know where we are. We don't even need to look out of the window now that we have GPS and sat-nav, and our satellites have replaced the stars. So next I want to talk about power, because views of the cosmos, how it works, have always been really important in shaping who gets to be in charge on Earth and why, shaping our political structures. So again, through much of history, the heavens were seen as divine, often celestial bodies seen as gods. And so rulers often modeled themselves on these celestial bodies or on the sky, wanting to sort of use that divine power to display, cement their own status. So we've got the Egyptian pharaoh Akhenaten, who was known as the son of the sun. Roman emperors often modeled themselves on Jupiter, who was Zeus, king of the gods. We've got the Chinese Emperor Wu, who was known as the Son of Heaven. More recently, the French King Louis XIV was known as the Sun King. So they're all modeling themselves on these celestial beings with their divine power that they wanted to channel to give them the authority to rule on Earth. But more recently, as our ideas about what the universe is have changed, we don't think that celestial bodies are gods anymore. That has fed through into our political systems, even shaping the democracies that we live in today. So just to explain what I mean by that, the physicist Isaac Newton in the 17th century, he revolutionized physics when he showed that the motion of everything in the universe, from a particle to an apple to a planet, it's all obeying the same universal laws of motion and gravitation. They're all moving according to those same rules. And that was really influential, not just in science, but in wider society as well, because it kind of led to a question. People thought, well, if everything from particles to planets, everything in the universe has to obey the same universal rules, shouldn't that be true for people as well? Shouldn't everybody from commoners to kings have to obey the same natural laws? And that idea was very influential during the Enlightenment into the 18th century in emerging debates about democracy and human rights. For example, in Europe, people were debating the evolving relationship between monarchs and their governments, and people were using astronomical celestial metaphors to guide their thinking and communicate their ideas. In France, Montesquieu, for example, who's famous for his balance of powers idea, he's talking about he says, it is with this kind of government as with the system of the universe in which there is a power that constantly repels all bodies from the center and a power of gravitation that attracts them to it. So he's really talking about the balance between centrifugal and centripetal forces that Newton was talking about as holding planets stable in their orbits. And thinkers like Montesquieu wanted to replicate that in society. They wanted the same balance of forces to hold citizens stable in their orbits. Over in America, these ideas reached there as well. So one of the key figures who was calling for revolution at the time was Thomas Paine. And he was also using Newtonian astronomical ideas. So at the time, the colony of America was often described as a planet orbiting the central sun of England. And Paine argued that in nature, satellites are always smaller than the planet or the star that they're orbiting. And so because America is bigger than England, that proved that it shouldn't be a dependent colony, that it needed to be independent and break free. So he's using that astronomical metaphor or idea. And then after the revolution as well, the founders of the new United States were debating how are they going to set up this new democratic system? For example, how tightly controlled should the states be by federal government? And they didn't all agree. Some are saying that the states ought to be left to move freely in their proper orbits. Others thought their attractions and repulsions should be controlled, but they're all working now in this new Newtonian framework. They're not looking to divine powers for how this new political system is going to be set up. They want their society to be run according to logic and physical rules, just the same as with their universe. And then this showed through in how the new nation chose to present itself. So I mentioned before that America had been seen as this planet orbiting the central sun of England, but once it had broken free, it didn't really make sense to see the country as a planet kind of drifting on its own. So they came up with a new celestial inspiration and chose to show the states as a constellation of equal stars in the sky. I want to squeeze in a quick story about light, because light is where, through most of history, all of our information, it's still where most of our information about the wider universe actually comes from. And in the 19th century, astronomers dramatically changed what they could do with that light that's reaching us from the stars. So this is a story about William and Mary Huggins. They were husband and wife astronomers who lived in Victorian England, and they were among the first people to realize just how much information starlight really holds. So at the time, chemists knew that if you burn different substances in a flame, they will burn with different colors of flame. And they realized that if you split that light from the colored flame with a prism into a rainbow or spectrum, and then look at it through a telescope, sort of magnify it, you can see patterns of lines in the spectrum. And they realized that every chemical element forms its own distinct pattern of lines. It's like a fingerprint hidden in the light that's emitted that you can use to identify that element. So you could use this method to work out what's inside different substances that are burning. And what the Hugginses did was they applied that approach to the stars. So they had this giant telescope, this giant observatory in their garden. This is Tulse Hill in South London. So this is just around the corner from where I live. And they had this big telescope, but they didn't look through the telescope. They had a prism to separate the light into spectra, and then they compared the patterns of lines that they got with the patterns that they got from burning different elements on Earth. And doing that, they showed that the stars are made of exactly the same chemical elements, the same building blocks of matter as objects on Earth. And you might think, well, that's pretty obvious. But at the time, this is something that scientists thought was impossible ever to know. The stars are so far away, we can't get samples of them. So they figured, well, scientists could study the appearance of the stars or their behavior, their motion through the sky, but they wouldn't ever know what they're made of or how they work. And yet here was a way to do that. There's these signatures that were hidden in the light. And that was the birth of the field of astrophysics. So now we have hugely powerful telescopes that look not just at visible light, but the entire electromagnetic spectrum from ultraviolet to infrared. But they're all based on exactly that same principle of separating the light into spectra. And this is really, it's opened up a whole new understanding of the universe and really changed human culture, because the stars are no longer these mysterious orbs in the sky. They are now physical objects that we can study and understand, and our myths about the stars have been replaced by evidence-based explanations of how the universe works. So spectroscopy has shown that nearly every atom in our bodies was once part of a star, for example. Spectroscopy has also shown physicists about the life cycle of stars, so understanding how they develop through their lives, and that's enabled the identification of completely new kinds of celestial objects, things like black holes, supernovae, neutron stars. It was also a red shift in the spectra of starlight reaching us on Earth that first told astronomers that galaxies are flying away from us in every direction. The universe is expanding, and that led in turn to the theory of the Big Bang. So now we have a scientific creation story for the universe. So we have this amazing new understanding now of the sky, of our universe, that stretches far beyond what's actually visible to us in the sky. But I do think there's an irony there as well, because nobody actually looks through these telescopes. The photons reaching us are picked up by electronic detectors and they're analyzed by computer. So now all of our information about the stars, our understanding of the heavens, is coming from our calculations and our instruments. There's really no longer any need for us to actually look up for ourselves at all. And that same thing is happening in everyday life as well. As I've touched on, our technology, we've got artificial light and heating. So we've got a constant climate, a constant food supply all year round. We've got clocks and GPS to tell us when and where we are. We've got our screens to watch for entertainment. So we don't need to be looking up at the stars, and we're becoming much more disconnected from what's going on above our heads. And that gives us an incredible amount of freedom and convenience in how we live our lives. But scientists are also realizing that this disconnection from our environment can also have downsides. So neuroscientists have looked at what happens to our brains when we regularly use sat-nav to navigate, for example, and they found that it changes our brains. It erodes our awareness of our surroundings and our ability to find our way for ourselves. Measuring time more and more accurately, it turns out that the more accurately we do that, the less time we feel that we have. More accurate clocks are contributing to a phenomenon that psychologists call time famine, where you're constantly rushing to meet deadlines and appointments and always feel like you never have enough time. And that in turn is impacting on people's physical and mental health. Our separation from the cycles of the sky is affecting our physiology more directly as well. So we now know that almost every aspect of our biology relies on the cycles of the sun, but also of the moon to regulate it. So everything from sleep and mood to digestion, kidney function, even cell division, are all dependent on these biological clocks that are kept in time by the sun and the moon. So if we become disconnected from those cycles, there are health impacts, everything from obesity and depression to heart disease and cancer. Even wildlife is suffering from being disconnected from the sky. So artificial light pollution now affects more than a fifth of the Earth's land area, and that's having really severe impacts on wildlife. It's disrupting bat feeding, bird and turtle migration, amphibian breeding, plant growth, plankton migration. It's killing insects by the trillion. So looking back over this long history, we have got this incredible scientific understanding of the universe now. But what really jumps out for me is that as we've developed that and relied more on our calculations and our technology and our instruments, we have also sidelined our own personal connection, our own experience of the sky. Even when that's damaging our health and our environment, much of humanity no longer sees our view of the stars as really telling us anything useful or important. So I wanted to finish by just coming back to one more reason why I think the stars are still important today, which is this emotion of awe and what happens to us when we see the stars. So the astronaut Chris Hadfield described his first spacewalk like this. He said he was in the space station getting suited up. He was completely technically prepared, ready for his mission. And then he stepped out into space. And he said, I was attacked by raw beauty. It was stupefying, he said. It stops your thought. He said he could see the velvet bucket of stars stretching on forever in one direction. And then in the other direction, there was this amazing kaleidoscope of color pouring by as the planet turned beneath him. And he said it taught him the power of the presence of the world as told to me by my ability to see it. And I think that's really lovely on the importance of it being a person, a human being up there in space who could see our Earth, see the stars, and rather than it just being a machine up there, a person who could really appreciate and understand the vastness and the beauty of that. And we get similar experiences and insights when we look up at the stars from Earth as well, when we get a chance to see them. So a truly dark sky is something that I've only experienced a couple of times in my life, but when you do, it's mind-blowing. And this has a name as well, celestial vaulting, when you feel lifted up into the stars and as if you're one with the cosmos. And as I mentioned at the beginning, psychologists are finding that these experiences of awe are really important to us. They make us more creative, more curious, less stressed. But also there's that shift in perspective where people become more generous, more outwardly focused. They feel more connected with the people and the environments around them. They're more likely to help a stranger, care less about money, more about the planet. So it seems that experiencing the vastness of our universe, sort of letting go of control and really experiencing what's beyond us is really important for us in shifting our attention and our focus away from those small daily concerns and towards seeing ourselves as part of a bigger picture. And that really feeds through into how we live and the decisions we make. Psychologists have warned of what they call awe deprivation in modern society, where our increasing focus on small screens is making us more selfish and narcissistic and isolating us from each other. And so I think what that's telling us is that our view of the stars does still matter today, that connection with vastness that feeds through into how we live. As a species, we are facing so many global challenges, and I think we're going to need science and technology to understand those problems, come up with solutions, but to turn that into action, to make the changes that we need to make to live peacefully and sustainably, I think we are also going to need some awe. So I hope I've convinced you over this talk that our view, our personal view of the stars does still matter. It's a crucial part of our cultural heritage. It connects us to people all through history and all around the planet. It's important for our biology, our physical and mental health, for the species that we share this planet with. And then looking at that research on Awe, I think the stars do still have the power to inspire and guide us today. And so I think that our view of the stars is worth fighting for before it slips away completely. When we talk about the importance of protecting nature, protecting our environment, I hope that as well as forests and oceans, we can include the stars in that, and not as something distant up there, far away from our lives, but as a really vital part of our surroundings, our experience, our well-being right here. Thank you.